Welcome to another video on vcloudlabs. In this video, we're going to talk about elastic system design and how to prevent traffic spikes from turning into cascading failures. We've all been there, right? The pager goes off, the alerts are screaming, and all the dashboards are glowing a terrifying shade of red. Your beautifully engineered system is just buckling under a massive, unexpected wave of traffic. It's pure chaos, and it's a feeling we know all too well. So, what's our first instinct? Panic, probably. But right after that, it's to throw more hardware at the problem. Spin up more servers, add more capacity. But that's just reacting. What if the problem isn't the traffic spike itself? What if the real flaw is in the very design of the system trying to handle it? Okay, let's pause on this for a second because this one idea is a total game changer. It completely reframes the entire situation. We stop thinking about brute force and start thinking about smart, resilient architecture. The problem isn't the surprise party. It's that we didn't build a house that could handle a crowd. So why do our systems actually fall over? Honestly, it's rarely just because the traffic went up. It's because the system was built on a deeply flawed fundamental assumption, the idea that traffic would be nice and predictable. Which, spoiler alert, it never is. Look, just having a bunch of extra servers sitting around waiting, that's just an expensive band-aid. It doesn't fix the core issue, which is that everything is tightly coupled. The request comes in, the work has to happen right now, and the cost is locked in. Our job is to snip those threads. Alright, so where do we even begin? The first, most foundational principle is this. You must separate the traffic showing up at your front door from the actual work happening inside the factory. They are two completely different things. And this really requires a shift in how you think. An incoming request is not a command you have to obey this instant. It's just a user raising their hand saying, hey, I'd like something. A truly elastic system knows how to separate the act of accepting that request from the act of actually doing the work. So how do we create that separation? With queues and event streams. Think of them as giant shock absorbers for your entire architecture. Instead of a request directly hitting a service and starting a long chain reaction, the system just says, got it, thanks, and tosses the work onto a to-do list, a queue. This lets you absorb a huge flood of work without drowning. And the difference in the outcome is, well, it's night and day. In a rigid synchronous system, that spike means error rates go through the roof and your service goes down. But in an elastic system, the queue just gets longer. Yeah, latency might go up for a little bit, but the system stays available. And believe me, availability is the first thing your users will notice. Okay, so we've got our buffer, we've got our shock absorber, we're holding back the flood of work. Now we actually have to do that work. And this brings us to the next piece. The services themselves have to be designed to stretch in an instant. You know, autoscaling is completely useless if your services aren't built for it. So here are 3 non-negotiable rules. First, they have to start in seconds, not minutes. Second, they have to be stateless. All the important data lives in a database or a cache, not on the instance itself. And third, keep their startup logic as simple as possible. At scale, startup time isn't a minor detail. It's a critical feature for reliability. Now this next part is so critical. How do you decide when to scale? A lot of people use CPU, and that is one of the biggest anti-patterns out there. Why? Because CPU is a lagging indicator. It's a measure of pain. By the time CPU is high, your users are already feeling it. The right signal is a measure of demand, like the depth of your queue. This lets you scale ahead of the problem, not in reaction to it. But let's be real, what happens when even a well-designed, super elastic system hits its absolute limit? It doesn't have to be a catastrophe. A truly resilient system has a plan for this moment. It's designed to bend gracefully instead of shattering into a million pieces. And that plan is called back pressure. Now don't think of this as a failure. It's a feature. It's a sign of a healthy, self-aware system. It's the system's way of intelligently saying, whoa, hang on, I'm at capacity, instead of just falling over and dying. And there are very real ways to build this in. You can rate limit traffic right at the edge. You can put a hard cap on your queue sizes. Or, and this is a really powerful one, you can gracefully degrade some features. You have to decide what's mission critical. Maybe during a spike you can drop analytics events, but you absolutely have to process payments. These are design decisions you make up front. The goal here isn't to prevent every single failure. That's impossible. The goal is to contain them. One overloaded service should never be allowed to start a domino effect that takes down the entire platform. That's why we use patterns like bulkheads, which are like watertight compartments on a ship, and circuit breakers. They ensure that a small fire stays a small fire. Let's just zoom out for a minute here, because this isn't just about a few technical patterns. Building truly elastic systems requires a complete shift in philosophy. It's a new mindset that touches everything, all the way down to how you think about cost and how you prepare for the unknown. And elasticity has to work both ways, especially when it comes to money. It's not just about scaling up to meet demand, it's about scaling down aggressively when that demand goes away. A system that can handle 10x traffic but costs you 10x all the time isn't a win. Your cost structure needs to be just as elastic as your infrastructure. So here's the one question I want you to take back to your teams. What breaks first? And are we okay with that? You absolutely have to know the answer to this before an incident. This is why we do load testing. This is why we do chaos experiments. You find your own breaking points on your own terms. That way, when something does break, it's not a surprise. It's part of the plan. So it really all boils down to these three pillars. First, decoupling, separating the traffic from the work. Second, prioritization, knowing what's most important when things get rough. And third, humility, the simple acceptance that traffic will be unpredictable and that things will fail, and then designing your system with that reality in mind from day one. And that's the ultimate takeaway, isn't it? This was never really about building bigger systems to handle more traffic. It's about building smarter, more resilient systems that can handle surprise, without everything catching on fire. When you truly design for elasticity, a traffic spike stops being a crisis and just becomes another Tuesday. Hey, thank you so much for joining us for this explainer.
If this helped you think a little differently about how to build resilient systems, please do us a favor and follow and subscribe to the vCloudlabs channel for more content just like this.